Okay, we're now in heart video 2. So where we were talking about that blood comes into the right atrium, goes through the tricuspid valve, comes from 3 sources: superior vena cava, which drains the head; inferior, which drains below the heart; ostium of the coronary sinus, which drains blood to the heart itself, goes through the tricuspid valve, 3 cusps, goes into the right ventricle. The right ventricle contracts down, pushes up, and closes the valve, and then attains enough pressure to open this, which is the pulmonary. Takes the blood into the lungs, gets oxygenated, comes back. There are 4 holes into the left atrium. 4 holes into the left atrium. So it comes back in the pulmonary veins and then goes through the bicuspid valve into the left ventricle. Left ventricle squeezes down, closes the valves, and then the blood will go into the aorta to the rest of the body. So that's the circulation. So here's the pathway of blood through the heart. 2 sides. Right side's the pump for the pulmonary, and the left side's the pump for the systemic. So when you look at the heart, you can see that the wall of the right ventricle is thinner than that of the left, because the right ventricle only has to take blood to the lungs, and you don't want to. If you take too high of a pressure to the lungs, you'll blow out the lungs and be bleeding from the lungs and throwing up blood. The left ventricle has to take blood to the whole systemic circulation, about 50 or so thousand miles of blood vessels. So it has to be very strong to be able to hurl that blood through the body there. Okay, so that's what we look at there. Here again is to show you that that right side takes it through the pulmonary circulation, and that left side takes it through the systemic circulation, which is the rest of the body. That it goes through the lungs, picks up oxygen, comes back with oxygen, and then now here's the situation. Arteries you normally think of as oxygenated, veins deoxygenated. Okay, but the term artery means is any blood vessel leaving the heart. Any blood vessel leaving the heart. It has nothing to do with whether it has oxygen or not. So therefore, in this situation, the pulmonary artery, which leaves the heart, has a more deoxygenated blood, and the pulmonary veins have oxygenated. Because again, we have to go back to the root of the word, and the root of the word is blood vessels leaving the heart are arteries, those coming back are veins. Okay? So pathway, right atrium, tricuspid valve, right ventricle to pulmonary, semilunar valve, pulmonary trunk, pulmonary arteries, the lungs, and so forth like that. Okay? And then from the lungs, the pulmonary veins, the left atrium through the bicuspid valve, left ventricle into the aortic and aorta, and then the systemic. So study that heavily. Okay. Equal volumes of blood are pumped from both sides. So when the 2 sides squeeze down, they're pumping blood. It's not the volume, it's the pressure. It's not the volume, it's the pressure. The pressure on the right side is less than the pressure on the left side. Okay, here again is to show you that that's a thinner wall on the right ventricle than the left ventricle. Now the coronary circulation, coronary comes from the word to crown around, because those blood vessels crown around the heart. They crown around, and this is the blood supply to the heart itself, because it's a living tissue. This is the one, when clogged, you can get a heart attack. Okay? So when we look at the coronary circulation, the blood comes out. Okay, we want oxygenated blood. So where do we want the blood to come from? I want you to think about that. We want it to come from the left ventricle. So the minute the blood comes from the left ventricle, there are 2 holes right above the aortic valve. 2 holes on the sides. Those two holes lead blood into the right coronary artery and the left coronary artery. So when blood comes up, some of it will go into the aorta, the majority, but some will percolate to the side holes, which would be the opening of the right coronary and left coronary artery. The blood then will start with the left, will then go into the left. The left coronary artery comes down and then it bifurcates. It bifurcates into a branch that goes straight down the front of the heart. Okay? This one in biology is called the anterior interventricular because it's coming in on the outside of the heart about at the same angle that the interventricular septum. This one here is called the circumflex because it goes to the back of the heart. Now, each of these vessels supplies different areas. These vessels here are called perforators. They don't have any particular name. They're called perforators. So this anterior ventricular, now in clinical, which you would hear, most of you going clinical, we'll call this the anterior descending branch. It handles most of the front of the left ventricle and some of the right ventricle. This one handles a lot of the side of the heart on the left side and the back. Okay? Then this blood vessel here will go and take care of the right side. It has this marginal branch, but this is the right coronary artery. It goes around and also branches down to give you a posterior interventricular artery, and sometimes it may come off the left. Sometimes it may come off of both. Now, you have to understand that collateral circulation is when you have more than one blood vessel going to an area. If a person, this is going to seem strange to some of you, if a person had a heart attack, sudden blockage of blood flow to the heart, and they were 18, Joe's 18, Jim's, let's say 74. If I said who would be the most likely to die from a heart attack, I'm sure that you probably would say the 75. I'm going to say no, the 18. Because at 75 on this American diet, you would have built a lot of new blood vessels. Now, AP1, we call that angiogenesis. Get that word down. Angio, A-N-G-I-O, genesis, G-E-N-E-S-I-S. Angiogenesis is the development of new blood vessels. So this angiogenesis would occur to give better collateral circulation. So the older gentleman would have more bypass routes. The young guy would not have developed that. So you have a lot of perforators as you get older. A lot of these unnamed blood vessels, these perforators. If there's only one artery going to an area, we call it an end artery, E-N-D artery, an end artery. It was only one. Okay? So that, now what will happen is, which we haven't done blood vessels, these are the arteries. The underneath here, which you don't see and wouldn't see, blood would percolate underneath into the interior of the heart muscle, which you don't see. And then it would become capillary. So it would go from artery to arterial capillary, and the capillaries would deliver oxygen. Then it would turn around and come back into venules and veins. So this here is kind of like the water main in front of your house. The water main in front of your house goes down the street from the city. But branching off would be the pipes going into your house. Assume this is the water main, and underneath would be the pipes going into your house. Then it would loop back, and then go into the coronary veins. The coronary veins, there are not as many of them. You have an anterior cardiac vein, a great cardiac vein, but ultimately all these veins will enter in something called the coronary sinus. All of these veins, and then the coronary sinus will dump its blood back into the right atrium. Which was my X1, the mouth of the coronary sinus. So that's how the circulation, now I encourage you to read on it. I went through it. That's how the circulation, the coronary, again, that's the circulation. Here's the coronary sinus. That's the circulation that can get blocked off. And that's the one that gets blocked off and gives a heart attack. That's the one that gives a heart attack. And where it's blocked would determine where the occlusion is. So therefore, if we looked into the blood vessels, we call it coronary angiography, they would try to find where's the blockage and then do some manipulation or treatment to try to unblock it, shall we say. Okay? So this is what they're showing, that angina pectoris, pain in the chest, can be caused by different things, but generally it's caused by heart. A decrease in blood supply to the heart. Term I want you to understand. Write this word down. Ischemia. I-S-C-H-E-M-I-A. I-S-C-H-E-M-I-A. Ischemia means decreased blood flow to an area. Ischemia means decreased blood flow. So you could have ischemia to certain areas of the heart, which would then give this chest pain. Myocardial infarction is the heart attack itself. Prolonged blockage. Infarct means that the area died and built up an infarct, scar tissue. Built up an infarct, scar tissue. Okay? Now, the heart valves are unidirectional, as we alluded to. You want the blood to go one way and not be able to go back the other way. And that's why what you have are these vessels, or shall I say these cardiac tendini and papillary muscles that hold back where you prevent backflow. The tricuspid valve, go back and study it and read it in your book, is between the right atrium and right ventricle. The bicuspid valve is between the left atrium and left ventricle. Now, someone took the bicuspid valve and bent it. Apparently they were a Roman Catholic, I'll say. And they looked at it, when they bent it, it looked like the mitres hat. The mitres hat is worn by the bishops and archbishops. And so they called it the mitral valve. So the mitral valve is another name for the bicuspid. We mentioned the cardiac tendinae. The semilunar valves have 3 half-moon shapes. 3 half-moon shapes. Okay? The atrioventricular valves are tricuspid and mitral. They go from the atria to the ventricles. The semilunar valves, there are 2. The aortic and the pulmonic. The aortic and the pulmonic. And again, they prevent backflow. Backflow takes blood back the wrong way. Here's an example of these valves. Here would be the tricuspid valve. See, it's 3 leaflets. That's the one between what? The right atrium and right ventricle. Here is the 2 one, the bicuspid, which when bent looked like the mitres hat, called the mitral. What's that between the left atrium and left ventricle? These are 3 half-moon shaped valves, known as the semilunars. One semilunar takes blood from the left ventricle into the aorta, which goes to the systemic, and the other takes it from the right ventricle into the lungs, which is called the pulmonic. Okay? Here again, you're looking at it there. See that mitre hat I mentioned? See, like that 2 leaves? Okay. All right. Half moon. So here again is looking at it again in that picture. Here again is looking at it. See how these cardiac tendinae are being pulled by the papillary muscle to try to keep the valves from going back the wrong way. Oh, here's a term. Prolapse. P-R-O-L-A-P-S-E. Prolapse. That means when the valves do go back the wrong way. Remember, in clinical, that's when things go wrong. So you can have prolapse. The most common prolapse is in the mitral valve, known as mitral valve prolapse, and it's a little more common in females than males. Then blood might go back the wrong way. Of course, the prolapse may not be enough to send it back the wrong way. We'll end here and pick it up there in video 3. This is the end of video 2, heart video 2.